All right, so let's practice differentiating between compounds that contain polyatomic ions and compounds that contain regular old elements. And let's look at the differences and bring this all together and see how we treat them differently. So the first example, we've got sodium, which tries to give away one electron, and it wants to bond with carbon, who's having a party with oxygens, a group, a polyatomic ion. And this polyatomic ion has to gain 2 electrons. So what is the formula, and then what's the name of this compound? The first thing I want you to think about every time is, are you including an anion that is just a single old boring element on the periodic table, or is it a polyatomic ion? Because the rules that you're going to follow are different. So in this case, we have a polyatomic. So we'll just make a little note there. You could put a little X or put a dot. I don't care what you do, as long as you acknowledge that this has a polyatomic ion in there. That's going to change things. So now, +1, -2. Compare the charges. If they're not the same, you got to crisscross them. So the 2 is going to go after the sodium. The 1 is going to go after the carbonate. So the 2 from the carbonate is going to go after the sodium. And then you write the formula for carbonate. The 1 is going to come after that. So I'm not going to write anything. Just Na2CO3. What do we call this? Sodium. Just write the name of the metal. Sodium does not make more than 1 charge. And I'll give you a heads up. None of these elements, none of these metals make more than 1 charge. They all make single charges, so we don't have to even worry right now about Roman numerals. We will in the next section. But sodium, and then what's it bonding with? This is a party. This is a polyatomic ion. If you forget what it's called, look it up. But this is called carbon 8. It's a party. All right, Ag is silver. Silver is trying to hook up with N with 3 oxygens stuck together. And the only way that N and 3 oxygens can stick together is if they gain 1 electron, so they're going to gain it from the silver. And these 2, positive and negative, are going to get stuck together. This is a polyatomic ion. So what's the formula? Well, this was giving up 1, this is gaining 1. That's a 1-to-1 ratio. So 1 of these and 1 of those. Notice I wrote NO3. You have to put NO3 there. All right, so silver and then nitrate. That is the name. Silver nitrate. 8 because it's one of those parties. Now the next one, we got magnesium trying to hook up with just N. Not a party, just N. Plain old element on the periodic table. So when we write the formulas here, we're going to crisscross. The 2 from the magnesium is going to go after the N. So we put a 2 there. The 3 from the nitrogen is going to go after the magnesium. Put a 3 there. That's your formula. What's the name? Magnesium. Just write the name of the metal, and then N. Plain old element on the periodic table. Change the ending to "ide." So magnesium nitride. So think about when you use 8 and when you use "ide." Potassium hooks up with plain old S. S, the anion, is just 1 element on the periodic table, so we're going to change the ending to "ide" when we get to it. So K hooks up with S. We write K, we write S. We're going to crisscross the charges. The K is going to end up with a 2 after it, and the 1 goes after the S. Imaginary 1. Don't even have to write anything here. So it's K2S. What do we call that? Potassium. And then since it's just plain old S on the periodic table, we have to change the ending to "ide, so it's sulfide. Aluminum is hooking up with this big crazy thing. This big crazy thing, 1 sulfur hanging out with 4 oxygens, is not sulfide, but it's sulfate. So aluminum is trying to hook up with sulfate. This is a polyatomic ion. We've got to think about what we do here. So watch how this one plays out. This is a complicated one. The aluminum and the sulfate are my 2 ions. I'm going to write them down. Write the formulas for my ions. Then I'm going to think about my charges. Aluminum's +3. I'm going to make a little note to myself. Sulfate is -2. Little note to myself. Now I want to crisscross them. The 2 from the sulfate is going to end up here after the aluminum. Al2. The 3 from the aluminum is going to go after the sulfate. And this is what we just talked about. If you are going to write the formula and then put a subscript after it, you have to write the formula in parentheses. So the S, the O, and the 4 goes in parentheses. Then you're going to write the 3 as a subscript. So that 3 is going to end up down here. But before I'm done, I need to wrap sulfate in parentheses. SO4. Communicate. It's 1 S and 4 O's. That 4 doesn't go anywhere. They're glued together. So Al2, SO4 in parentheses, with a 3 after it. This is the most complicated you can get. If you're good at this, then you're all set here. All right, what do we call this? Write the name of the metal. Aluminum sulfate. All right, let's move a little quicker here. We got calcium hooking up with plain old phosphorus. This is one element on the periodic table. Boring. We change the ending to "-ide." We're going to remember that when we write the name. Write your symbols. CaP. Think about the charges. Calcium's +2, phosphorus is -3. Use those to crisscross. The 2 goes here, the 3 goes there. No parentheses because there's no parties. It's Ca3P2. This is calcium, and then I get to my anion. It's one boring element on the periodic table, so it's phosphide. Now I have zinc hooking up with P that's already bonded to all these oxygens. So this is a polyatomic. This is a party going on. So I'm going to write my formulas. Zn makes a little +2. I'll make a note for myself. Phosphate is PO4 that needs to gain 3. I'll make a little note there. Then I crisscross them. The 3 is going to come here. The 2 is going to go after the phosphate. I'm going to write a 2 after this crazy mess here. I have to wrap the formula of the polyatomic ion in parentheses and have that 2 outside. So Zn3, PO4, 2. What do we call this? Zinc, and because it's a polyatomic, all I have to do is name it. Phosphate. See the difference? 8 and "-ide. Party, single boring element. Magnesium's hooking up with this guy here. This, I know it's simple, it's not as crazy looking as phosphate here, but it's still more than one atom, polyatomic. So magnesium, I write Mg, make a little note, +2. This OH is hydroxide, so I put OH. Make a little note, -1. Crisscross them. The 1 from the hydroxide goes here. I'm not going to write anything. It's an imaginary 1. But what's more important is the 2 is going to end up after hydroxide. Is hydroxide a polyatomic? Yes. The rule is, I don't care how basic it looks or how complicated it looks. If you are going to write a number on the right of a polyatomic ion, you have to wrap it in parentheses. Even though there's no number. Kids mess this up all the time. Like PO4, they see that 4 and they wrap the 4 in parentheses because they don't want the 4 ending up next to the 2 and making it look like it's 42. Here, they don't see a number, so they just kind of assume they don't have to wrap it in parentheses. You have to. If you don't, this is what you're communicating. If you wrote MgOH2, you're telling me that there's an Mg, one of these, there's one O, and there's 2 hydrogens. That's not the case. When these guys bond, it's Mg giving up an electron to this hydroxide, and Mg, because remember it gives away 2, giving up another electron to that hydroxide. There's 2 O's and 2 H's. That's why the whole thing has to go in parentheses. So MgOH in parentheses, 2. Magnesium hydroxide. Not oxide. Oxide's plain old O, which we're going to see in the next example. All right, so we got lithium bonding with oxygen, plain old boring oxygen. Remember, that means we're going to change the ending to "-ide. So it's Li, make a little note, +1. Oxygen, -2. Crisscross them. The 2 comes here. Li2O. This is lithium oxide. Oxygen changes to oxide. Hydroxide, oxide, 2 different things. Make sure you get them right. All right, and finally, the toughest one. We have polyatomics all over the place here. The first one is NH4. The second one, let me get this out of the way here. The second one is CO3. Make a little note. This is +1. This is -2. Those numbers are not the same, so we got to crisscross it. The 2 is going to be written on the right of a polyatomic. The rule is, if you're going to write a number on the right of the polyatomic, wrap it in parentheses. NH4 in parentheses, 2. And then CO3, because we'd be writing a 1 after it, we don't really write anything. So it's just one of them, no parentheses. What do we call this? Ammonium carbonate. Ammonium carbonate. All right.